In this video, I'll talk about tree diagrams. Now, tree diagrams are just a nice visual way of representing possible outcomes, and it's going to help us calculate some probabilities. Now, the leaves themselves are the events, like heads or red or not 7, and we're going to label the branches with the probability of successfully reaching that event. Halves, thirds, 7/16, that sort of thing. First example, we're going to flip a fair coin twice. Now, half the time, of course, it'll be heads, and half the time it'll be tails. Tree diagram that will come up here. The blue branches represent the first flip, and the purple represent the second flip. Now, probabilities don't change from one to the next because flipping a coin is independent. The second flip has nothing to do with the first flip. Now let's look at the probability of getting heads twice. Well, we're going to follow from the root all the way along the branches until we get to the end. We're going to multiply the probabilities along the branches, and we add if there's more than one path. So if we get more than one path, we multiply along the branches until we get to the end, and we add on the next set of branches till we get to the next conclusion, and so on. You'll see what I mean in just a second. So only one way to get heads twice, that's heads and heads, so that's half times a half, and that's the probability of heads twice being a quarter. How about getting one of each? Well, this is where there's two possible outcomes. We can get heads first then tails, or tails first then heads. So you can see what I mean. We're multiplying along the branches for the second time, and we add those two results together. Add it all up, it's simplified. Probability of one of each is 1/2. Here's one of some marbles. We've got 3 red, 2 green, 8 blue. We select one out of the bag, record its color, put it back in. That's important that we're putting it back in. It's called with replacement. We're going to select another marble, record its color as well, and we want to know some probabilities. So 3 red, 2 green, 8 blue. That gives us 13 total. You can see here purple branches being the first pull. We put it back in. That's why the numbers don't change for the second. Orange branches being the second pull. Now, what if we want to say select green twice in a row? Well, one way to get green twice in a row, follow along the branches. 2 out of 13 for the first pull, 2 out of 13 for the second. So that's 4 out of 169. What about selecting a red and a green? Well, here now we have 2 different ways of getting red and green. We can have red first then green, or green first then red. Follow along. That's 2 possibilities to get there. Add them together, and we get 12 out of 169 ways of getting a red and a green marble together. Now, what about the possibility of, say, no red marbles? 4 different possibilities here. We can have green and then green, green and then blue, blue then green, or blue and blue. So that's 4 different things we're going to have to add together. There's the first 2, starting with the green each time. As I said, be systematic about this. It's the best approach. Adding to that, of course, the times we start with the blue marble first time, blue, green, and then blue and blue. Multiply all that out, and we get 100 different ways of not getting a red marble out of 169. And that's it for this video.